Hey everyone, welcome back to my channel. In this video, we are going to solve this problem on LeetCode. Find all numbers disappeared in an array. So we are given nums array, which contains a range of values from 1 to n. N is here is the length of given array. So there are some numbers missing. For example, in this array, we have few numbers missing. So and basically, as we know that length is 8, that we expect we need to have all numbers ranging from 1 to 8. So we have 1, we have 2, we have 3, we have 4, we don't have 5. So 5 is missing, and we don't have 6 as well, and we have 7, we have 8. So these missing numbers, we can just return them inside the list. So there are multiple solutions for this problem. So one is using range and using range of until 1 to n plus 1 and checking all nums exist in array. So the time complexity of this solution is O of n squared, because we are searching too many times. So we are searching on each iteration of range. So range is equal to n. So the overall operations are n squared. So space complexity here is constant. We are not using extra space. And the second approach is using hash set and checking range exist. So by using hash set, we are just improving the performance of searching compared to the first solution. So this increases the time complexity to be linear of n, and space complexity here would be O of n as well. So it's linear because we are using extra memory hash set. And the third solution would be sorting the array and checking their continuous numbers. If not, then we can assume that we can easily find the numbers that are missing. So the time complexity of the solution would be of log n log n. So this is, and space complexity, if we are allowed to modify the input array, it would be constant space. And the fourth optimal solution would be using indices as indicator that number has occurred or not. So let me explain the solution by drawing the example. So we have this input array, right? So we just iterate through this array, and let's imagine that we are on here on the first iteration. So we have number 4, and as we told that we are going to use the indices as an indicator that number has occurred or not. So the number 4 means that we are going to update the fourth index to be minus of it. So we have -7 because are we calculating? So we are basically calculating 4 minus 1. So this gives us index, and we just convert it to -1. And on the second iteration, we have 3, so we are going to go to index 2 and update its value. So it will be -2, and so in here we have 2, so we are going to get modulus absolute value of this, and going to go the index 1 and make it negative. And here we have 7, the index number 6 would be negative, and 8, so we are going to go index number 7 and make it negative, and we are going to go here, so we have index 2, but we have seen it in here, so it means it's a duplicate value. So we can just go here again and make it negative. So if it's already negative, then leave it as is. And then we are same happens with this number, because we have the number 3 occurred previously, and we have 1 here, so we are going to go index 0 and make it negative. So this is on the first iteration, and in the second iteration we are going to pass through this array one more time and try to find non-negative elements. So that means for example, 4 has indexes. Now we work with indices. That means like the index value, if it's minus, so if it's negative, then that number has occurred. So index +1 has occurred in our nums array. And then we go through and try to find positive numbers. So here we have 8, here we have 2. That means the indices 4 and 5 incremented by 1 are not in the list itself. So in this way, we are finding this missing numbers. So the time complexity of this solution is O of n, and the space complexity of this solution is O of 1. So this is the best approach that we can come up with, and let's code this up. So first, let me write comments just to make sure I follow the steps correctly. So first, we are going to iterate nums I minus 1 should be negative. And in second step is find positive elements and add I plus 1, so index +1 to our results. So let's get started. For I in nums, so we are working with, as we are working with indices, then we need indices as well. So we have index and value here. We enumerate nums, and so we are going to go and find, so the number can be negative, so we are going to find absolute value of number and subtract 1 here and go to z index of nums array. If it is already less than 0, if it's negative, then we can we can just update it. If it's positive number, then let's take this and update it to be minus of this. Okay. So basically this is enough for this algorithm, and we are going to find positive elements in the nums. So we have result array, and again for I num in enumerate nums, if, so we have num here, if num is greater than 0, we're going to append that index to our result I plus 1. Then we can return our result array, resulting array. So we have updated, and let's check with this small example. So let's test our code. Testing with this input. On the first iteration, we are on here, and we are going to go to the index 0 because num is 1, and we are going to go index 0, and if it's greater than 0, then we are going to make it minus. And we are here now, and we are going to do the same, but this condition will not be met, so we are going to move to the next step. So we are going to find the positive values in our nums array. So in the first iteration it's negative, so we don't add anything to our result array. In the second iteration, the index number 1 has a value that is positive. That means that the number 2 has not occurred, so we are going to append that to our result. So let me run this just to make sure this order is correct for enumerate, and we can submit this solution, and it works. Thanks for watching. Bye bye.